Humans have always been interested in finding ways to live longer. The oldest surviving story in recorded history is Mesopotamia's 4,000-year-old Epic of Gilgamesh, and this desire shows up even there. After the death of a close friend, our hero Gilgamesh becomes afraid to die and starts a quest to find eternal life. Along his journey, he hears about a few things that might help him live forever, but he's foiled at each turn. Someone tells Gilgamesh that he will live forever if he can stay awake for a week, but he's unable to do it. He picks a plant that only grows at the bottom of a lake, but the plant is stolen before he can use it. In the end, he's told that living forever is impossible for him. But that hasn't stopped the quest for the perfect life-extending herb or routine. Everything from red wine to fish oil has been purported to help you live just a little longer. But does any of that stuff actually work? What does science have to say? I'm Amy Briggs, executive editor of National Geographic History magazine, and you're listening to Overheard, a show where we eavesdrop on the wild conversations we have here at Nat Geo and follow them to the edges of our big, weird, beautiful world. This week, I interview longevity researcher Matt Kaeberlein about the science of living longer and his own search for an elixir of life using an invention he calls the WormBot. It's a machine that uses artificial intelligence to test new aging drugs on tens of thousands of microscopic worms. All that and more right after the break. I'm here with longevity researcher Matt Kaeberlein from the University of Washington. I wanted to find out what happens to our bodies when we age and what actually works when it comes to staying healthy for longer. Hi, Matt.
Hello.
I want to start with the science of aging. Age-old question. What is aging?
If you think about the selective pressures that go along with evolution, that's mostly about reproduction, right? Achieving reproductive age and then passing your genes on to the next generation. Once you've had your children, right, and passed your genes on to the next generation, evolution doesn't care anymore, right? You're done. And there's a lot of evidence accumulating that it's actually the continued expression of those developmental pathways that contribute to the declines that go along with old age. So in some ways, biological aging may be the absence of natural selection because there's no reason to keep older animals, older people alive from an evolutionary perspective once you've done what you needed to do.
So I think that sort of leans into a question I had, a broad one, just of why do people age? Like, what happens?
Sure. So I think what you're asking is, from a biological perspective, what's actually happening there, right?
Exactly. So why do we go into decline? Why does my hair change to gray? It's stuff like that.
Right. We've gotten in many ways beyond that purely conceptual framework and actually started to understand at a cellular, at a molecular level, what are the processes, what are the genes, what are the proteins that are driving the biology of aging? Things like telomere shortening, cellular senescence, stem cell dysfunction, protein misfolding. So there are 9 of these hallmarks of aging that seem to be fundamentally important for the physiological changes that happen when we go from being young to old. Those hallmarks create a physiological state that is susceptible to all of the diseases that we associate with old age. And when you look at the major causes of death and disability in every developed country around the world, essentially all of them have age as their greatest risk factor. So, this isn't shocking, but from a health perspective, it's really the biology of aging that is driving the onset and progression of all of these different diseases and functional declines that go along with old age.
So it sounds like expanding the human lifespan has to do with expanding or delaying the onset of these 9 things at your cellular level.
Yeah, absolutely. And I would say even more important potentially than expanding the lifespan is expanding what we call health span, the period of life that's spent in good health, free from chronic disease and disability. There are a whole lot of people who are living longer with 1, 2, 3, 4 different diseases of aging. So I think that's really the promise of what we call geroscience or aging research, is the opportunity to let health span catch up, and so that we can hopefully push those diseases of aging back as far as possible.
So I want to make sure I'm understanding this correctly. Lifespan is just how long you live. So from the
Yeah.
time you're born to the time you die. And health span is more about the quality of your life. How do you measure health span? I don't want to be like,
That's a fantastic question. And so health span from a quantitative perspective, how do you measure it? I think is actually one of the important questions that the field is grappling with right now. You can measure kidney function, you can measure heart function, you can measure, does a person have cancer? Do they not have cancer? But how do you put that all together into one metric that we call health span? And I would say we don't have consensus yet on that. I think what we need to be able to do is come to agreement on what should we measure to get that sort of holistic assessment of overall health. I also think that in the geroscience community, we need to pay more attention to psychological and social aspects of health. But we, as scientists, basic scientists, which is the world I come from, we tend to focus a lot on disease, right? And that the aspects of health that are clearly associated with major killers. In the geroscience community, there aren't a lot of people thinking about mental health and psychological health. But from a quality of life perspective, that's really, really important. And those things change with age as well. So I think we need to spend a little bit more time thinking about that, how that fits into the sort of overall picture of health span.
It certainly, health span certainly sounds like a complex matrix of things. Certainly not as easy as like you're born on this day and you die on this day and that's how long you live. One of the things I wonder about too, talking strictly in terms of lifespan, do you think we have an idea of how long the human lifespan can possibly be? How long do you think it's possible for a person to live?
The longest lived person lived a little bit over 122 years. So that means statistically, it's very, very, very unlikely that anybody under normal human existence is going to live 140 years or more. So then the question is, what's the maximum possibility if we could target these hallmarks of aging? Then what would the maximum lifespan be? And the answer is we don't know. Like nobody's done that experimentally. So we don't know what the answer would be, even in a laboratory animal. What I can tell you is the biggest effect that people have had on lifespan in a mouse is about a 70 to 80% increase in lifespan.
Wow.
So, that's pretty big, but it's not immortality, right? So I would say that there's no fundamental reason why we couldn't do the same thing in humans if we understood the biology well enough. Can we get beyond that? Again, hypothetically, sure, but nobody's done it in a mouse, so I'm very hesitant to say that we're likely to do that in people anytime soon.
So it seems like too, in like terms of popular science, you go into a bookstore and you go into like the health and wellness section and it's just noisy and crowded with books on longevity.
Yeah.
What?
My advice would be don't.
Yeah. Okay. Don't go into the bookstore for that.
No, don't go into the health and wellness section on longevity. Yeah. There's very little credible stuff out there, unfortunately.
Like what can regular people do to distinguish, the good ideas from iffy ones?
Anybody who promises immortality or extreme lifespan extension, and they don't make it clear that that is very, very far away at best, is somebody you should not pay attention to. Mm-hmm. I think people who use terms like immortality, reversing aging, things like that, tend to be overly optimistic at best and dishonest at worst. Honestly, that was a really long, rambling answer that didn't say anything. So I don't know that you want to include this. I'll let you decide what you want to include.
No, I think I got a lot out of it, which is stay out of the health and wellness section.
I wouldn't say that. So here's my view on health and wellness from the perception of longevity, right? I think that there are some things that are rock solid you can take to the bank, but they're not going to surprise anybody, right? Mm-hmm. So, maintaining a healthy weight, exercising regularly, getting good sleep, that's a hard one because it's not obvious how you do that. Those things all definitely impact the biology of aging. They absolutely will have an impact on your health span and probably your lifespan. Caloric restriction is the most effective non-genetic intervention for increasing lifespan in mice and rats.
When longevity researchers say caloric restriction, what do they mean? That sounds like diet.
Yep.
But
this is super important, right? So what has been shown is that complete reduction in all the macronutrients by a fixed percent, let's just say 50%, If you do that in a mouse or a rat, there's a high likelihood that you will increase lifespan at the population level by 50%. So that's been done multiple times.
In other words, the research shows that eating fewer calories helps mice live longer on average. Matt told me that's part of what makes studying longevity diets difficult. It's really hard to change the kind of food you eat without changing the number of calories. These studies on calorie restriction have led some people to try diets like intermittent fasting. But before you try that, Matt says there's one big catch.
There are lots of people who will write books based on the mouse and rat studies saying that people should do these same sorts of interventions. They just leave out the fact that about 1/3 of the time, it's actually harmful in mice and rats. We don't know if that's true in people, but it might be. And so I'd be a little bit concerned about recommending anything to people that has a 30% chance of shortening lifespan, in the laboratory studies.
Mm-hmm. Why is it difficult for scientists to discover, say, food or drugs that help with longevity? Is it because you're going from laboratory animals to human research? Is that part of the complication, or?
A mouse in the lab will live about 3 years. So those are not short experiments. They take time, they're expensive. And then in people, the real challenge becomes, how do you prove it? Pick your favorite diet or drug or supplement. How do you prove that it is or is not having an impact on biological aging? Even if you started the treatment at 50 years old, that's going to be a 3 or 4 decade lifespan study on, thousands of people to get a significant result, right? So I think it's just not pragmatic to think that we're going to be able to do definitive longevity studies in humans.
This is where Matt Kaeberlein's research using animals comes in. We're going to take a short break, and after that, I'll ask about his research on worms and dogs. We're back with researcher Matt Kaeberlein, who's searching for new ways to help people live longer. His biggest project is a survey of tens of thousands of pet dogs. So I want to pivot now to your own research. Could you tell me a little bit about that work?
Sure. So the Dog Aging Project is a large, what we call longitudinal study of aging. So these are all companion dogs living with their owners, and we follow them over time to try to understand what are the most important genetic and environmental factors that influence healthy longevity in companion dogs. To do a lifespan study in people, we're talking about, 40 years. To do a lifespan study in dogs, if it's powered appropriately and you're starting with the right cohort, we're talking just a few years. And that's because dogs age biologically about 7 to 10 times faster than people do, right? So the largest part of the Dog Aging Project is a purely observational, as I said, longitudinal study of aging. There, we don't ask the owners to do anything different than they normally would. We just collect information on the dogs every year over their lives, really to try to understand as much as we can, just based on what the owners can tell us about the dogs. So just by completing the 2 surveys, though, the owners become part of what we call the Dog Aging Project PAC, which is the foundational group of the Dog Aging Project. There's about more than 41,000 dogs in the PAC right now. And then there's a much more in-depth studied called the Precision Group. Every year, the dogs go to their own veterinarians. We send them a kit, and we get blood chemistry, metabolome, microbiome, epigenome every year on those dogs. So that's really the bulk of the non-interventional part of the Dog Aging Project.
So is the dog years thing actually true? The 1 human year equals 7 dog years?
It's close, right? So it's certainly not perfect. So there's 2 things to say. One is, big dogs age faster than small dogs. Anybody who's had a Great Dane is going to recognize that they have a relatively short lifespan of maybe around 8 years on average, whereas a Chihuahua can live to be, 15, 16 years, no problem, right? So there's a big size effect on rate of aging in dogs. The other thing that's really, I think, been interesting is it turns out that dogs do age on average about 7 to 10 times faster than people, but that relationship changes over the dog's life. So very early in life, dogs are aging maybe 12, 14 times as fast as people are. And then when the dogs hit middle age, that slows down. And towards the end of their lives, their biological aging is maybe 3 times faster than people. So it's not a purely linear relationship across the lifespan of the dogs.
So one of the other projects that you've been working on is nicknamed the WormBot. Can you tell me
Yeah.
about your work with nematode worms?
Sure. So nematode worms have been a very powerful model in the biology of aging for a few decades now, really because they age very rapidly. So the lifespan of a mouse, I said, was about 3 years in the laboratory. The typical lifespan of a nematode worm is about 3 weeks. So greatly compressed lifespans. They have the same hallmarks of aging at the cellular and molecular level that we do, that dogs do, that mice do. And they show functional decline. So we can look at lifespan in worms, and to some extent, we can look at health span in worms. And when I say worms, people will immediately think of earthworms. If you've never seen a C. elegans, Google it. Beautiful movies. The elegans, of course, for elegant, right? They don't look at all like earthworms. They're actually quite beautiful animals up close.
How big are they compared to earthworms?
The C. elegans are about 1 millimeter, so you can see them visibly, but you're not going to be able to pick out any details unless you look under the microscope. We like them because we can do genetic studies and drug studies to try to find things that can affect lifespan and health span, and it doesn't take as long. But the traditional ways of doing lifespan experiments in C. elegans involve human beings sitting at a microscope, watching the worms, and then as they get old, just like in people, they slow down, so they're not moving as much. So then you have to kind of tap them, and there are these tiny little picks that people use. It's kind of funny because you're looking under the microscope and it looks almost like this giant hockey stick coming in on the worm, and you kind of, you tap them and see if they move. And when you tap them and they don't move anymore, then you consider them dead. So it's very time consuming and tedious for people to have to sit and do this for every animal in every experiment. So we'd been thinking for a while about ways that you might be able to partially or completely automate this process. And the system we developed is called the WormBot. It's a robot that moves a webcam over little petri dishes. And we just have the robot take this webcam and take a picture every 10 minutes of every plate. And then we use an AI-based system to, from those images, tell us where is each worm in each image at each time. And because we get images 10 minutes apart, we can tell if the same worm has moved during that 10 minutes. And if a worm hasn't moved for a long enough period of time, let's say a couple of hours, then you can assume that worm is mostly dead. So this has been really powerful for us because now all of a sudden we can do true high throughput automated lifespan analysis, and we're starting to be able to get health span metrics from this as well. Now, this is great for us, but I think the real reason why I've pushed so hard for us to develop the WormBot is because I've had a feeling for a while now that as people started to feel like we understand the biology of aging, everybody stopped looking at what we didn't know and started studying what we did know. The problem in my mind is that I think there's a lot we still don't understand about aging. And I felt like we needed some tools that would allow us and others to take a step back and say, okay, if we can measure 10,000, 100,000, maybe even 1 million different interventions, we can take a true unbiased approach and let the biology tell us what's important. And my hope is that when we can do 100,000 experiments a year, that we'll find things that nobody else knows about. We don't know yet. We'll have to do the experiments, but I think that's really the only way that we're likely to find new interventions with big effect sizes. Of course, that will be in C. elegans. So then there's the question, what we find in C. elegans, will it translate through to humans? That'll be years of work to keep me employed. So that's the real goal here. How do we keep Matt employed for the next couple of decades?
But it sounds like it's the, increasing the number of experiments you can do every year in these worms to sort of delve into these areas of the unknown.
The more you learn about almost anything, but particularly a scientific area of discovery, the more you realize how little you really know. So I hope that this will be one path that will help us kind of break out of that.
To round out our episode on longevity, I wanted to talk with someone who's actually got some personal experience. So I hopped on the bus with my producer, Brian, and we rode down the street from National Geographic headquarters to the home of Willie Mae Avery. At 107, she's the oldest living person in Washington, D.C. When we spoke with her on the phone before the interview, she said, "I must be getting very old if National Geographic wants to talk to me." She's not wrong. Think about it. The year she was born, 1915, before the U.S. even enters the First World War. I mean, it's mind-boggling when you consider how much the world has changed since then. I mean, forget television. She was born before the first commercial radio station. And she lived through everything, from the Great Depression to World War II, from the Civil Rights Movement to the dawn of the digital age. We arrived at her tidy fourth-floor apartment on a sunny afternoon where we sat in her living room, surrounded by photos of friends and family and other mementos of a life well lived. So we've just got a couple questions. I have to tell you, I would never guess that you are the oldest person in Washington, D.C. by looking at you. You look fantastic. So for our listeners, can you tell us your name and a little bit about yourself?
Well, when you're saying a little bit about it, there's a whole lot to be said, but my last job, I retired from GW Hospital.
Mm-hmm. What did you do there?
I was a surgical technician.
Oh, wow.
Yeah, I like to work in surgery.
Wow, that's a high-pressure job, working in surgery.
It is, but I loved it.
How long did you do that for?
14 years.
14 years. Mm. So it sounded like a long time working. What did you do before surgical technician?
Well, I was the first black person that was a male clerk at the Concrete Masonry Association. You know, that's where they make cement.
What are some of your childhood memories?
When I was a little child, I start remembering little things from, I believe, maybe about 3 or 4 years old, things in the way my mother taught me. Mm-hmm. I never will forget those days.
So it's good to have people around you.
Oh, my goodness, I have so many friends. I love people. Mm-hmm. I love everybody.
So we know you've lived a long time. What would you say are some of the biggest changes you've seen in history? When I think about what the world was like when you were born and how it is now, there have been so many changes. But what were the biggest changes that you saw that made your life different?
The phones. Mm-hmm. You used to have a phone that the box was on the wall, and then you had to ring it like that. Mm-hmm. A lot of changes in the people. For instance, when I became a file clerk for the National Concrete, one guy that working there, he didn't want to work with blacks, and he quit. Mm-hmm. So the boss at that time, he called me into his office one day, and I thought, oh my God, I will lose my job. And he said, but I consider being a full-time file clerk. It really makes me feel good. It's just so many other things I just can't think right now, really.
So what do you think led you to have such a long life?
You know, that is a hard answer. Everybody, all my family's gone except 2 nieces and 1 nephew and a lot of cousins. Mm-hmm. I still think about, why am I here? Why did God put me here for a purpose? And maybe it's what I'm going through now with the people around me who care for me. Right now, that's about the only answer. Mm-hmm.
Do you have any advice for people who want to live longer?
Be kind and nice to elderly people.
After our talk, Willie Mae Avery showed me some of the pictures of her friends and family, many of whom come to visit with her every week. I met a few of them over the phone, and they all had such nice things to say about her. I don't know this for sure, but I think a big part of her secret is having a network of people who care about her. Thank you again.
I thank both of you so much.
Thank you. Have the wonderful rest of your afternoon. At the end of his story, Gilgamesh never finds a way to extend his life. And we haven't made much progress in the last 4,000 years. For now, there is no medicine, food, or supplement proven to help you live longer than regular exercise, good sleep, and a healthy diet. My personal takeaway is that if I'm able to maintain friendships like Willie Mae Avery, I'll at least live a happier life with the bonus of a few more years. If you like what you hear and want to support more stories like this, please rate and review us in your podcast app and consider a National Geographic subscription. That's the best way to support Overheard. Go to natgeo.com/explore more to subscribe.
I'm Fran Smith, writer of the magazine feature on longevity. Matt Kaeberlein is just one of many researchers working hard to find ways to help people live longer and stay healthier as we do. One of the most exciting things is how we feel about aging really has an influence on how well we age and even how long we live. To learn more about the cutting-edge science about the biology and psychology of aging, take a look at our magazine feature. We've included a link to the story in our show notes.
We've also included a link to the story of how the 4,000-year-old Epic of Gilgamesh was rediscovered and deciphered. Like Gilgamesh, Chris Hemsworth is on a mission to live better for longer. With the help of top scientists, he takes on 6 epic challenges to test mind and body to the max. Limitless with Chris Hemsworth is now streaming on Disney+. All this and more can be found in our show notes. They're right there in your podcast app. This week's Overheard episode is produced by Brian Gutierrez. Our other senior producer is Jacob Pinter. Our producers are Kyrie Douglas and Alana Strauss. Our senior editor is Eli Chen. Our manager of audio is Carla Wills. Our executive producer of audio is Devar Ardalan, who edited this episode. Our photo editor is Julie Howe. Hansdale Sue composed our theme music and sound designed this episode. Michael Tribble is the director of integrated storytelling. Nathan Lump is National Geographic's editor-in-chief. And I'm your host, Amy Briggs. Thanks for listening, and see y'all next time.